would help us kind of get a first pass at that categorization. This is an example message that we're actually using for these devices here, and that we're using for our first pass of this. This is kind of loosely at the very beginning how we envision communications using this protocol to look like. So just very simple, using message IDs, origin IDs, destination IDs, timestamps. I'm not going to get into the context type because I probably need a whole nother talk to that, but that's just a way to abstract out so that maybe different hardware can talk to different software. And what is the type of this interaction and what is the value? So with a simple message like that, building up again, based upon all the different types of interactions that we categorize them, that's actually how the APIs would be talking in this idea. It also leads us to a kind of different method of thinking a little bit, where software becomes more centric to what we're doing. So currently we think about software on top of hardware. Software is built for a particular piece of hardware, or in combination with hardware and operating system. In this case, the only time you really have to think about that is if you're actually building the SaaS product, right? If you're actually building the web-based server, because then you're still running on Linux or Z or Windows or whatever it is, right? But beyond that, all interactions are happening with this messaging system, with this protocol. So you no longer have to think about that piece as the application designer once you've created the server stack. It's also service focused. I talked a lot about this, so I'm not going to rehash this too much here. But this again is that idea that we don't need that application wrapper anymore. The UI, the interaction part, that's done by the hardware. We don't need to think about it as a software designer. I don't need to worry about how my hello world message is received by the different pieces of hardware. I just accept that the person building that client for those pieces of hardware did their job correctly, and that the user is going to understand the intent of my message when they complete that interaction. And lastly, this means that it's very loosely coupled. It's very easy for me now to change out the different pieces. I can change out my hardware that's connected to the interaction points on my software, and I can change out the software that's connected to my hardware. It would probably involve a little bit of marketplace ecosystems, not unlike, this is very far-fetched at this point, what we experience with Android and iOS, where you would go and you would say, these are the software pieces that I have available to me as the consumer, and these are the hardware pieces, and in there you would most likely connect them. What are the interaction points of those pieces of software, and how do the pieces of hardware you said have proclaimed that they make available the different pieces so you can link them up. So one last thing I just want to mention is loosely where my mind was kind of evolving from. The only real kind of work I've seen that's similar to this, honestly, at least from what I've seen, and I do want to hear more, was the work done by Tim Berners-Lee when he was working on the semantic web. It's very similar in idea. His idea was a way to make any amount or type of data understandable on the web. And not all of it was really fully realized. There are certain pieces of this that we think of now when we think semantic web. We think, removing CSS and JavaScript from HTML, but that's not really what it was all about. At its core, he really wanted a way to universally describe data and have it understood by any computer using it. And it's not unlike what I'm trying to do here. If you think about how HTTP works, if you have a browser that understands HTTP, then any two computing devices can understand HTTP. I'm just looking at it from the aspect of, well, input and output is the one universal thing that we use to communicate with all computers. Let's abstract there. So that's kind of a similar approach that I've been building off of. Most of the other work I've seen in IoT to try to abstract the hardware and software is built around proprietary APIs, either in software by which they use, like if it's Node or Java or whatnot, or how they do it, whether it's REST or SOAP or those kinds of things. So with that, so take questions.
One of the advantages that you pointed to was this idea of next-gen service asks the device, do you support this message type that I want to send? And the device comes back and says, well, I support these. Maybe it's going to have to look through a list and say, well, okay, it doesn't have this service, but it doesn't understand this message, but it understands this message, which is kind of like an older version.
Well, the burden, honestly, the burden will be on the design of SIOP. Because if SIOP is designed correctly, then intents can be described accurately. There will be obviously different versions of it, and I'm sure it would evolve. So just like any other protocol, you would have to declare the version that you wanted to communicate with. And then at that point, if we've done our job right, there shouldn't be that much space for ambiguity. Because whatever intent you had, that hardware is responsible for describing it in actual reality.
It seems like there's an opportunity for graceful degradation there, right? As a new version of SIOP comes out, there, maybe not in all cases, but in many, you could map it to an older version when there wasn't direct compatibility of the versions. Maybe it could be mapped to the closest analog.
Yes, and if we do our job right, perhaps it would be where each iteration maybe just got more refined. So maybe where there was one interaction before, now maybe there's 5 different variations of it, and then yeah, you could always revert back to the older, more broad version.
I mean, that happens. I mean, you gave the analogy to JVM. I mean, that's really how JVMs work too. I mean, there is functionality is degraded out, as things change. But the only way that the JVM world works is because of the fact that the Java has been accepted, and so all the suppliers of hardware want to be compatible. So they build a JVM that sits on their machine that will run the Java. And so the only way this will work is if there is wide acceptance of your semantic your SIOPs.
Absolutely. You would need the client for everything, and by everything, you're now talking about the embedded world.
One more question?
So is there, we're talking about 2 things. One is the protocol and one is the OS, kind of.
There really is no OS, at least from the perspective of what's being discussed here. There would be an operating system on the server running, obviously, the client software, or not the client software, sorry, but the service software. But there is no OS. A mobile operating system could theoretically be replaced with this too. You could have a SIOP client on a tablet, and whatever interactions were going on at that moment is the one that you would interact with on the tablet. The actual processing would be done in the cloud by whatever software is driving those.
So the SIOP is the protocol?
SIOP is the protocol.
Is it standardized or standardized like a consortium standardized for all the IoT?
This is something that I'm just trying to start getting going with. So it's very much in its beyond infancy stage.
Great. So let's give a big round of applause to